Hey guys, it's Mr. Krieger. We're going to start our new unit, Unit 10, Lesson 1. This is the last unit. We're starting on this lesson, Parts of a Circle. This is a longish lesson. It's 8 pages long. Make sure you print it up. A lot of it is informational and most of it's not too difficult, so we should be able to cover a lot of this work successfully. Okay? All right, we're going to be talking about circles. And the definition is, a circle is the set of all points, r units, that's a distance, from a fixed point, O. O is going to be that center. Let me show you how that's created. Suppose you start with some point, like right here, point O. And let's say we're talking about our our R, our distance. Let's say that's, an inch. So from point O, let's find an inch. Well, that's an inch, and that's an inch, and that's an inch, that's an inch, and that's an inch, and that's an inch. There's an inch, and there's an inch, here's an inch, and here's an inch. And what you notice is happening is that you're getting, and again, I'm not really measuring it out, but you're getting a sequence of points that form a circle, and if you fill it in completely, you get this circle, okay? So you need a center and you need a distance, r, okay? O will be the circle's center, and r is obviously the radius, and I'm going to draw that in for you now. So I'll do that in a different color. Here is the radius, r, okay? And the radius is defined as any line segment connecting the center of a circle to a point on the circle. So let me make some points for you now. Let's call this point A. I'll make a line segment going across here. We'll make this B and C. Okay, so we're connecting the center of the circle to a point on the circle. So for example, OA, that's a radius, or OC is also a radius. Also, OB is a radius. Okay, those are all the segments that are the radius. Okay, theorem. All radii, that's the plural of radius, all radii of the same circle are congruent. So we could actually say that OA and OC and OB are congruent, and if I made any other line segment connecting O to the point on the circle, that would be congruent to these three. Okay, now a diameter, and you know this already, is any line segment connecting 2 points on the circle, but it must go through the center of the circle. Okay, so for example, BC is a diameter. It connects one end of the circle to the other, and it goes through the center of the circle. Okay, an arc is any curved portion of the circumference of the circle. Okay, so I'll highlight something for you, like maybe I'll do it in this green color. A to C, this curved part right there, that's an arc. Now we can name arcs in not name them, but we can classify them in 2 ways. A minor arc is an arc of a circle that is less than 180 degrees. By the way, a circle is 360 degrees. So anything less than halfway, that will be called a minor arc. I'll show you, besides for using that example, I'll just show you an example here. Suppose we have these 2 radii. This piece right over here, this piece would be a minor arc. It's less than halfway around the circle. On the other hand, a major arc goes more than halfway around a circle. So if we make this same kind of 2 radii, this angle again, the major arc would be going this way around the circle. So from here to here, but the major part, okay? So this is a minor arc, major arc, and a semicircle is exactly 1/2 of a circle, okay? All right, now we're going to talk about some types of angles that can be created with the radii. Okay, so you know when you go and order a brand new pizza pie, how do you slice it up? Well, all slices must go through the center of the pizza, right? And you would cut it. This is a pizza slice that hasn't been cut yet. You know what the guys do. They take their pizza cutter and they cut through it. And they make 4 cuts going straight through, okay? So they might cut it this way, and then this way, and then 2 diagonals. And then we'll go this way through, right? So the key is that all slices go through the center. We'll call it the center tip. I'm sorry, the tip equals the angle. So the angle is by the tip of the pizza slice. And the crust, this part here, that's the arc, okay? So the larger the crust, the larger the angle by the tip here, okay? We call this kind of angle here a central angle. So a central angle is an angle whose vertex is the center of the circle. So there's a central angle, angle by 1 there, right? And the degree measure, the way we measure it is, remember there's 360 degrees in a circle, so however many degrees we call this portion of the circle. So out of 360, let's say that's 70 degrees. This angle is 70 degrees. So the measure of angle 1 is equal to the measure of that arc. So this is brand new. A circle has 360 degrees. A portion of a circle is going to be less than 360 degrees. The way we define the amount that there is going to be the same as the measure of that angle. So if that angle is 70 degrees, that arc will be 70 degrees, okay? So here's a theorem, just basically a fact. The degree measure of an arc, not the length of the arc, but the degree measure, is equal to the measure of the central angle that intercepts the arc. So the measure of this arc is the same as that measure of that angle, as we were saying, as I said before. Okay, so here's an example. In this diagram, angle AOB is 130 degrees. Therefore, this minor arc AB, I'll actually put the little, we weren't able to get the symbol, so that's how we would designate arc. It has a little round thing on top as opposed to a bar. So the angle is 130 degrees, so that arc is 130 degrees. And now you could try some problems on your own. But before we do that, I want to mention one other thing. Just to remember how to figure out what the angle is, remember this. Whatever the center angle is, it's the same as the arc. Okay, so hopefully that center same. Hopefully that will help you remember that fact. Okay, so now you could try some of these problems. You could pause and try to figure out these different examples here. You could pause it, but I'm going to go through it. So we got to find the measure of this arc, minor arc AB, which is designated with this X. Clearly that's 42 degrees. Now here we have the arc is 45 degrees, so we need the measure of that central angle. That angle is going to be, I'll just put equal 45 degrees, okay? What is the degree measure of an arc created by a semicircle? So let's think about that. You have a circle, cut it in half. How much is that? Well, we know that this is a 180 degree angle, so this arc from here to here, and I'll highlight that portion for you, this is going to be 180 degrees. Okay, here, you're given a central angle of 30 degrees. What do you know about the two intercepted arcs? So you have you have like vertical angles here essentially. Both these angles are 30 degrees. What do you think is going to be true about those arcs? They're going to both be 30. So they're both equal. So they're both 30. And that brings us to this theorem. In a circle or in congruent circles, if central angles are congruent, then their intercepted arcs are also congruent. Okay? So if you have, I'll just draw you another example. I don't have to make even vertical angles. Let's say we have one angle here and one angle. Let's mark those two angles. Let's say those angles are both 20 degrees. Then these arcs will be equal and they'll both be 20 degrees. Okay, so you should be able to do this, these problems as well. Okay, so what do you think? The measure of angle AOB is 56 degrees as it's marked. What are the measures of the following? Arc AB. Well, you should know that. That's going to be 56 degrees. What about arc CD? Well, these are vertical angles. This is going to be 56 degrees, so arc CD is also going to be 56 degrees. Now you have to think about what is the measure of arc AC. You might say, well, how am I supposed to figure that out? But you know something about geometry. What's the relationship between these two angles, COD and AOC, those two? Well, they're a linear pair, right? Those two angles form a linear pair. So therefore, 180 minus 56 is 124. This angle here is 124. Therefore, arc AC is the same. It is also 124 degrees. Okay, let's try this one again. You can pause the video and you can try the problem on your own. So let's see what we got here. Let OA and OB be opposite rays, basically making a diameter. And angle AOC is 75 degrees. Let's find the measure of angle BOC. Again, we know that these are a linear pair. 180 minus 75 is 105, so this angle here is 105 degrees. How about arc AC? Simple. The central angle is equal to the arc, so this has got to be 75 degrees as well. How about arc BC? Central angle is 105, so this arc is 105. How about arc AB? Well, AB is a semicircle. It's a half of a circle. So that's going to be 180 degrees. And finally, arc BAC. Let me mark that for you now. BAC, it's giving you 3 letters because it wants you to start at B, go all the way around A to C. I've kind of got off the line here, but you get the idea. How big is that arc? Well, you are going to take this arc, which you know is 180, and add on this arc, which you know is 175. So 75. So you're basically doing 180 plus 75, which is giving you 255. The arc that goes from B through A all the way to C is 255. By the way, that arc is a major arc. It goes more than halfway, goes more than half the distance of a circle. Okay. So now, a couple of new things. Central angles, radii, and chords. Notice each central angle is made up of 2 radii. So like AO and BO make up a central angle. Each radius goes from the center to the edge. It does not go from edge to edge. A straight line that goes from an edge of a circle across the circle is called a chord. So here is an example of a chord. A chord is sort of like a diameter, except it doesn't go through the center of the circle. Let's say the center of the circle is right there. This is just called a chord. Here's another example of a chord. There's another chord. It connects 2 ends. It connects 2 points on the circle with one straight line, and that's what a chord is. The diameter of a circle is also a chord. It's just special. So the diameter, so I'll make a note over here, the diameter is a special chord. Okay? And the thing that makes it special, it's the largest chord and it goes through the center of the circle. Okay? Okay. Now we're going to take a look at a new type of angle. Now we learned about central angles. In fact, I don't know if you can see it on your paper. I don't know if you can see it on my paper. This, and I'll put a little O in there. Angle AOB, that's a central angle. But now there's another angle there. That's the angle that goes from here to here to here. Let's call that a C. Angle ACB is also an angle, but it's a different kind of angle. An inscribed angle is defined as an angle whose vertex is on the circle. Notice the central angle, the vertex was in the center of the circle, right at the circle center. But an inscribed angle, actually the vertex touches the circle on the circumference of the circle, okay? The sides are two chords of the circle, and the degree measure of this angle is not equal to this arc. It's actually 1/2 that arc. So this is what's different over here. I'll make a little star over here. Here's what's different. The measure of angle 1, I'll call this angle 1, is equal to 1/2 the measure of arc AB. So in our example, angle 1 here is going to be 40 degrees, okay? So fact, the measure of an inscribed angle is half the measure of the arc that it intercepts. So the arc is bigger, the angle is smaller, by half. Okay, so here's an example. In this diagram, minor arc LN, by the way, the reason they mentioned that it's a minor arc, you could actually go from L to N this way. That would be the major arc. So by calling it minor arc LN, you know you're going this way. This is 100 degrees, and they want to know what this angle in here is, angle LMN. What we just learned is that an inscribed angle is literally half of the intercepted arc. So that's going to be 50 degrees. One thing, again, I'm going to emphasize is central angle is equal to the arc. Inscribed angle is half. The angle is smaller. It's easy to find. You literally cut it in half. Here is another example. And here, instead of having one inscribed angle, we have 3 inscribed angles. Let's see what we know. We're given a triangle inscribed in circle O. Angle B is 70 degrees, and arc BC is 100 degrees. And we need to find all these things, the measure of arc AC. Well, what I'd like you to see is that if you just focus on this angle here, that's an inscribed angle with a central angle, an inscribed angle of 70 degrees. What do you think this arc is going to be? Is it going to be equal to 70 degrees? Think about what we just learned about inscribed angles. It's not equal to the arc. It's half. So should this be 35? No. It's going to be 140 degrees. So arc AC is 140 degrees. How about angle A? Okay, well, if we take a look now, this time I'm going to focus on the green angle. That's also an inscribed angle. And we know that it goes to this intercepted arc of 100. So how big do you think that's going to be? We know inscribed angles are half the arc. That's going to be 50 degrees. So let's put a little 50 in there. How about angle C? Well, here we have to use another fact about geometry. We know the angles of a triangle add up to 180. So you would literally take 70 and 50, add them together. Subtract that from 180. That's going to give you this angle is 60 degrees. Just by using what we know about triangles. The angles have to add up to 180. And finally, the measure of arc AB. There's 2 ways of doing it. One way is to use the fact that we just learned. An inscribed angle is half the arc, so we've got to double it to get that arc, 120 degrees. Another thing you could do is you could say, well, if the arcs of a circle have to add up to 360, and 140 and 100 already add up to 240, then we're going to need another 120 degrees for all the arcs to add up to 360 degrees. So far, so good. Okay, let's go to the next page. Okay. Inscribed and central angles that share an arc. In the accompanying diagram of circle O, the measure of angle ABC is 42. It's going to be hard for me to squeeze it in there. I'm just going to put a little mark there. That's 42 degrees right in there. What's the number of degrees in this angle right here, AOC? Well, let's do this in steps. Step 1 is to recognize that this was an inscribed angle, so the inscribed arc should be double. This should be 84. Because an arc is double the inscribed angle. Now we're looking at the central angle. We should know that the central angle is equal to the arc, so the measure of angle AOC is actually also equal to 84 degrees because it's equal to the arc, whereas the inscribed angle was half of the arc. All right, think about this. If an angle is inscribed in a semicircle, then it's a right angle. Why? Why is this angle a right angle? Similar concept. This arc, since this line is going through the center of the circle, it's a diameter. It's cutting the circle in half. This arc is 180 degrees. The inscribed angle, keep in mind that if the diameter wasn't there, then this would just be a regular inscribed angle. And this is the arc it goes to. The arc is a half of a circle, 180 degrees, so therefore the angle will have to be half, 90 degrees. Okay? In the accompanying diagram, isosceles triangle ABC is inscribed in circle O with diameter AOB. Find the measure of angle CAB. See if you could figure that out. One thing we just learned is that this angle was 90 degrees for that reason right there. But since this is an isosceles triangle, the base angles have to be equal. So 90 plus x equals 180. The angles of a triangle have to add up to 180. 90 plus 2x equals 180. 2x equals 90. You should have been able to figure this one out. The angle CAB is 45 degrees. And so is the angle CBA. Okay. What do we know about inscribed angles that share an arc? Okay, so now we're going to see some superheroes, but there's a good reason for that, as you'll see. It should help you remember things. I want you to look at this diagram here. See, the smiley face is the center of the circle. And I'd like you to see this angle is in black, and this arc is 90 degrees. This angle is in red. Its arc is 90 degrees. Imagine that these circles are the same size and these arcs are in the same position, and then if we took this circle and slid it on top of this circle, we get this diagram. So check it out. This angle is an inscribed angle, so what does its measure have to be? 45 degrees, because it has to be half of the arc. Same thing with this one. This has to be 45 degrees, half the arc. Putting them back in, 45 and 45. These arcs are equal. So here's the fact. In a circle, all inscribed angles that intercept the same or congruent arcs will be congruent. Now, I happen to call this the SpiderMan Theorem. That's what I put over here. I don't know if you see it, but when I look at this, I see like the Spider-Man's eyes. And when I see what looks like a bow tie or butterfly wings inside of a circle, as long as the 4 points touch the circle, then I know that these two angles here are going to be equal. So ADC, if ADC is 50 degrees, that's the angle right there, then what about ABC? Have to both be the same, so that has to be 50 degrees. Again, I'm going to just draw you a diagram, another diagram right here. I'm going to put in a bow tie. The ends of the bow tie, I'm going to put 4 points. Doesn't matter where they are, but I'm going to make the bow tie connecting all 4 points. Again, to me it looks like Spider-Man's eyes. These angles here have to be equal. Why is that? They both go to the same arc. Now, whatever the measure of that arc is, let's say that arc is 100 degrees, those angles have to be half, 50. I used the same example, okay? So again, to me, it looked like Spider-Man's eyes. So that's why I called it the SpiderMan Theorem, to help you remember it, okay? So here you could try it for yourself. In this diagram, angle BAC, that's this angle right here, is 39 degrees. What about angle BDC? It's the bow tie. It's the two angles on the same side, touching the same arc. That's going to have to be 39 degrees, okay? So that's the first superhero theorem that we came to. What you need to remember is if you see the bow tie, the two angles at either the two bottoms or the two tops are going to be equal. By the way, those aren't going to be 39, but whatever this angle is, this angle has to be as well. Whatever this angle is, this angle has to be as well. Okay. Here's another fact. Corollary is just a related fact to a given fact, so that's all it means. All this says is that in a circle, if two inscribed angles intercept congruent arcs, then they're congruent. So let's say arc AB and arc CD are equal. Then angle 1 would have to be equal to angle 2. Now, let's say arc AB was 24 degrees and arc CD was 24 degrees. Angle 1 and angle 2 would both be equal. I'm not going to equal 24. You know they're going to be equal to 12 degrees each because they're half. Inscribed angles are half. Okay, so here is the next superhero theorem, only because it looked like something to me. And here is the fact. In a circle, two parallel lines, like BC and AD, intercept congruent arcs. What do I mean? Arc AB and arc CD have to be equal. Okay, so if, let's say, arc AB is 30 degrees, then arc CD is also going to be 30 degrees. Now, I called this the Teenage Mutant Ninja Turtle theorem. You might say, what am I talking about? Well, I'll make a similar example right here. So you got your two parallel lines, right? It just looks like two parallel lines in a circle. But to me, I see one of the Teenage Mutant Ninja Turtles, right? You want to, make it a little more like seriously looking like that. Could add some features, but if you see what I mean, it looks like a Teenage Mutant Ninja Turtle. That's why I call it the Teenage Mutant Ninja Turtle theorem. The idea is, and I can show you why this is true. If you have any two lines that are parallel in a circle, then if you draw another line, I'll put it in a different color. Let's say we draw a line connecting these two. Well, then you got alternate interior angles, and when lines are parallel, remember in this case the lines are parallel, alternate interior angles have to be equal. Let's say this arc was 30 degrees, like we had over here. Well, this angle is going to be 15 degrees because an inscribed angle is half the arc, and this angle here is also going to be 15 degrees because they're alternate interior angles. Now, because this angle is 15 degrees and it's an inscribed angle, this arc has to be 30, and what do you know? These two angles have to be equal to each other. So if you have the two parallel lines, to me it looked like one of the Teenage Mutant Ninja Turtles, and hopefully that will help you to remember that those arcs there will be equal. And here's an example. Now you might say this example here, first of all, it doesn't look like the mask that it's wearing. Remember, I'm using this specific example to relate it to this superhero, but I want you to just think, anytime you have two parallel lines, these two arcs are going to be equal. So that's going to be x as well. You might say, how am I supposed to figure out what x is? Well, what do you know about the arcs of a circle? They have to add up to 360. So you can add 160 plus the two x's, and you know that has to add up to 360. So we get 160 plus 2x equals 360. If we subtract 160 from both sides, we get 2x equal to 200 and x equals to 100. So x is 100 degrees, okay? Let's try this one out. Find the measure of angle D. That's over here. Okay, so there's no parallel lines here. This is just to show you that don't always be looking for Teenage Mutant Ninja. Don't always be looking for the Teenage Mutant Ninja Turtle theorem. Think through the problem. We need to find this angle. if we highlight the angle, it's an inscribed angle, and it actually goes to this arc right here, the purple arc that I'm making this way. It started at A and it ends at C. So we need to figure out the length of that whole purple arc. Well, what we know is we know 3 out of the 4 arcs. We also know that the 4 arcs altogether have to add up to 360. Let me add what we have so far. 150 and 50 and 60 add up to 260. Subtract that from 360, CB has to be 100. The purple arc is 150 plus 100 is 250 degrees. And since this angle by D is an inscribed angle, it has to be half of that. So the measure of angle D is 125 degrees. Okay, last page. See, it wasn't too long. All right, here we have ratios. And it's telling you that the ratio of arc AB to BC to CA are 1 to 2 to 3. What that basically means is that arc BC is twice as big as arc AB, and arc CA is actually 3 times as big as AB. But what I would do if I were you, I would just say, well, I don't know AB, that's X. BC is twice as big, I'll call that 2X. And CA is 3 times as big as that, so I'll call that 3X. What do we know about these arcs? Well, we know they have to add up to 360. So we're going to solve that equation. And we get X is 60. This arc here is 60 degrees. This arc here is 120. And this arc here is 180. It's not drawn to scale, because if it was 180, it'd be going through the center of the circle, but diagram's not drawn to scale. Now we need to figure out the measures of the angles. Angle A is an inscribed angle across from arc BC. Half of 120 is 60. Angle B is an inscribed angle across from that arc, which is 180. Since an inscribed angle is half, it's going to be 90. Angle C is across from the 60-degree angle. That's going to be half, so therefore that's going to be 30. Okay, last fact. The inscribed quadrilateral theorem. If quadrilateral ABCD is inscribed in a circle, then the angles across from each other are supplementary to each other. Angle A and angle C have to add up to 180. Angle B and angle D, excuse me. Angle B and angle D also have to add up to 180. So if you take a look at this example here, find the measures of all the angles in the inscribed quadrilateral. The angle by E and the angle by G are across from each other. They have to add up to 180. Don't use angle H in this equation. You're going to do x minus 6 plus x plus 20 equals 180. The angles that are diagonally across from each other, they're going to add up to 180. So we get 2x plus 14 equals 180. 2x equals 166. And x equals 83. So this angle here is 83. So the measure of angle H is 83. The measure of angle E is 83 minus 6, which is 77. The measure of angle G is 83 plus 20, so that's 103. Then you might say, how are you supposed to find the measure of angle F? Well, this is a quadrilateral. The angles of a quadrilateral have to add up to 360. These add up to 263, and if we do 360 minus 263, we get 97. So the measure of angle F is 97. All right? Your homework is 3 pages, so make sure you cover it all.